Kia ora Year 12 and Year 11. This video is going to look at 3 different problems involving gradient functions. The first one is a pattern on Nulake, page 21. We're asked to find the gradient of the tangent to the curve when x equals 2. So I'm just going to sketch what this parabola looks like. So thinking back to graphing, we could rewrite this function as x minus 3 squared. So we know that it's going to be a parabola that just touches the axis like that. Okay, so there's a very bad graph of that function. It's good to do that sketch when you're doing these problems, and I'll show you in class how you can use your graphics calculator to help with that. So we can write the function y as f of x. To get the gradient, we need the gradient function, also called the first derivative. So f dash of x is equal to 2x minus 6. And what we're interested in is what is that value when x is equal to 2. So we can see from looking that what we're trying to find is the slope of the straight line, the tangent to the curve there. So we should be expecting a negative answer. We substitute in 2 instead of x, and we get 2 times 2 minus 6, which gives me negative 2, which fits with the graph, especially if I draw it more accurately. So that's the first kind of problem. Here comes the next one. Okay, here's the second kind of problem. So this should be labelled question number 2, not question 1. Right, find the coordinates of the point on the curve where the gradient is 2. So let's draw my curve again. So it touches the x-axis at x equals 3. And we know that that point there is 9. So this time what we're looking for is where on the curve will I get the slope being 2. Now that's not very accurately drawn, but it gives you the idea that I should be finding a number that's a little bit bigger than 3. So I'm again going to use the gradient function, right, which we can write in 2 ways. We can write dy by dx, or we can write f dash of x, and that equals 2x minus 6, just the same as before. But this time, I'm looking for the value of x that will give me this. 2 is equal to the gradient, which is 2x minus 6. So I get 8 equals 2x, x is equal to 4. So that's the first part done, but I need to find the coordinates of the point. Or even if it just said the point, a point always means an x value and a y value. So what I have to do now is to substitute x equals 4 into this equation. So we write that as f of 4 equals 16 minus 24 plus 9. Okay, which gives me 1. So the coordinates of the point are 4, 1. Alright, so that's the second kind of problem. Make sure you can tell the difference between the first kind and the second kind. Here, we're finding a gradient, so we have to solve for a value of x. In the first one, it's easier because we're given a value of x. Now we'll look at the third kind of problem. Right, this time we're going to find the equation of the tangent to the curve. Right, so we're using the same curve. So again, here we go. It's y equals x squared minus 6x plus 9. Touches the tangent here. And we're looking for what's the equation of the tangent to the curve when x equals 1. So there's 1 there. So we're looking for the equation of a straight line. At this point here, we have to figure out what that is. And we can tell it's going to have a negative slope. So the first step is to find f dash of x. So again, that's 2x minus 6. And now we're trying to work out what's the equation of the tangent to the curve for x equals 1. So there's a few things you can do next, but you might as well figure out what's the gradient at x equals 1. So f dash of 1 is equal to 2 minus 6, which is quite a steep negative line, negative 4. That is going to give me my m, my slope, to use in my equation of a straight line, which is y minus y1 equals m times x minus x1. Okay, so we've ticked off that. We also know the x value is going to be 1. So what we've got to work out next is what's the value of y, what's the coordinate of the point on the curve. So to do that, I put that back into my function. Right, so I'm using the function to get the y coordinate. So f at 1 is equal to 1 squared minus 6 plus 9, which is equal to 1 plus 3, so that's 4. Okay, so now I've got the point is going to be x1, y1 is equal to 1 and 4. Right, so we've got that and we've got that. So we have everything we need to work out the equation of the tangent. I'm going to try and squeeze this in down here. So we get y minus y1, 4, is equal to negative 4 times x minus 1. Now, rewriting that, I get y minus 4 equals negative 4x plus 4. And that gives me, oh, I really have run out of space. Never mind. I'm going to squeeze that in just up here. Okay, because I've just got one last line to do. So we get y equals negative 4x plus 8. So that's the equation of the tangent to the curve. Okay, so hopefully that helped. Questions on finding the equation of the tangent to the curve are on page 21 of Nulake. Questions where we work backwards to figure out the gradient, the coordinates where the gradient is a certain value, are on page 22. Thanks for watching.